All right, welcome back. During this lecture, we are going to talk about data types and especially the operations that we can do with data types. So, during this lecture, we will be focusing on integers and floating point operations, and they are specifically then arithmetic operations. In particular, we are going to look at different type of arithmetic operations we can perform, and also the order in which we perform these operations. So, we call them operator precedence rules, and then we see how we can apply them with integers and double values. So, integers and doubles in combination, and also we are going to talk about how we can do type conversion from integers to doubles as well as double to integers, right. Now, first of all then, in order for us to get some idea about what kind of arithmetic operations are available in the C++ programming language. So, we have 5 main arithmetic operations we can perform: addition, subtraction, multiplication, division, and the mod operation, right. So, let us take few quick examples and then see how these operations can be performed. Now, addition is pretty obvious like subtraction. So, we perform addition based on 2 integer numbers. So, the resulting number in this case will be 5. The thing is, in here then we can assign these values into variables. For example, we can say x equals to 2, y equals to 3, and then so we can say int z equals x plus y. Right. Now, when you are performing this operation, then so we will be taking value stored in x and the taking value stored in y and then assign it to z. So, after this operation, then value of z will be 5, right. So, likewise we can perform subtraction operation as well. Okay. The next is the division. So, when you are doing the division operation, so what we do is we divide the first number by the second one right here, and then put the integer result. So, since both of these numbers, so they are called operands. Since both operands are integers, so the resulting value will be an integer value, right. So, then for example, when you divide 14 by 7, so we can evenly divide 14 by 7. So, then this is going to be 2. Okay. So, however, when we divide, let us say 12 by 5, so 12 cannot be evenly divided by 5, but we have 2 5s in 12 and then something remaining. So, we are going to get rid of the remaining part. So, that is the decimal part, and then we get only the integer portion of the division. So, therefore, 12 divided 5 will result in 2. Okay. So, therefore, when we have 2 operands for the integer, the resulting value is going to be an integer value. Okay. So, the next operation is a mod operation. So, mod operation is getting the remaining value after the longer division. Okay. So, now in this case, so 12 divided by 5, so that is going to be 2 and then 2 remaining. So, then this remaining value can be extracted by applying the remainder or the mod operation, right. So, then 12 mod 5 is going to be 2. Okay. So, those are the 5 basic operations that we can perform with integers. So, most of these operations can be done with double values as well. So, we will take a look at them shortly. Now, the next question is then, so if we have more than one operation that we need to perform, so how we are going to perform that operation. Now, in here for this particular expression, so we have addition and the multiplication. Now, which one are we going to do first, addition or the multiplication? So, this is the case where we apply what is called the operator precedence rules. Now, according to operator precedence rules, so we have multiplication, division and the mod operation at the same level, and the next level we have addition and the subtraction. So, given this then, so we will be performing multiplication first and the addition second. So, the resulting value is going to be 3 plus 15. So, that is going to be 18, right. So, therefore, in here then, so we perform the highest precedence operation first and then we go to the next one and so on and so forth. Okay. Now, if we take another example, so in this scenario, so we have multiplication, division and the addition. Now, multiplication and the division have the same level of operator precedence. So, if you have a situation like this, then so we need to figure out whether we are going to do multiplication or the division first. So now we have another level of operator precedence. So in this case, we apply what is called left to right rule. Okay. So then we are going to perform the leftmost highest precedence operation first, and then go to the next one, and so on and so forth. Right. Now according to this rule, then so we will be performing the multiplication first, and then division second, and then addition third. Okay. So then first 3 times 10 is going to be 30. So then 30 divided by 5 plus 6. So that's going to be 6 plus 6. So then it's going to be 12. Right. So then if you have more than one operation with the same operator precedence, so we'll be performing left to right rule. Okay. So now suppose I want to perform a particular set of operation regardless of operator precedence rules first. So then we can apply the parenthesis across those operations. So then parenthesis has the highest level of operator precedence. All right. So then at the top level, so we have the parenthesis. Now in this particular expression, so then we have 3 times within parenthesis 10 divided by 5 plus 6. So now in this case, then so we are going to perform what is in the parenthesis first. Now inside that we have the division and the addition. Now we apply the operator precedence rules to what is inside the parenthesis. So then this will be the first operation we are going to perform, and then this will be the second operation we are going to perform, and then this will be the third operation we are going to perform. Right. So then it's 3 times. So 5 divided 10 divided by 5, that's going to be 2. Then 2 plus 6. So then this will be 3 times 8. So finally we will have 24 in there. Right. So then this set of operator precedence rules will determine the order in which we are going to perform these operations. Right. Okay, pretty good. So far then we have looked at integers and integer related operations. Now if you go into the summary of all of these operator precedence rules, so first of all then, so all the operations inside the parentheses will be evaluated first, and then we have the multiplication, division and the mod operation in the next level. After that we have addition and subtraction in the next level. Right. So if we have operators at the same level of operator precedence, so then we will be performing the left to right execution of these instructions. Right. Now it's the time for us to do a checkpointing question, and then see if we grasp these basic concepts. Right. All right. So now let's focus on arithmetic operations related to double values. Right. Now when you are performing then operations with integers, we know that the resulting value is going to be an integer. Now if you are performing operations related to double values, so we call them floating point operations, then the resulting value is going to be a floating point number. So that's pretty straightforward for us to understand. So however, now if we have a situation where we have floating point numbers and integer values together, so how we are going to perform this operation. Right. So let's get a couple of examples here, and then see if we have a situation with mixed expression, that is where we have more than one data type in the expression. Right. So in this scenario then, so we have an integer value and a double value. If we want to perform this operation, then we need to think about how this data are represented in the computer memory first. Right. So now integer is a 32-bit integer, then we have 35 as a double value, it's a 64-bit integer. So therefore when you think about the memory operation, so the way this data is stored in the computer memory, so we have 3.5 stored in much larger memory space than the integer value 2. So now if I want to perform this operation, then we know that they are not the same type. So they have then heterogeneity in the way that data is represented in the computer memory. So in order for us to do this addition, so either we need to convert 2 into a larger one or 3.5 into a smaller one. Now the way we can do this operation without losing any data is to convert the smaller one into a larger one. Right. So then what we do is, so we are going to convert 2 into 2.0. So with that we will be converting 2 into a 2.0 that is 64-bit double value, and then we will be performing the addition with 3.5, that is another 64-bit double value. So, now both of them are the same type, right. So, then this operation will result in 5.5, right. So, always then when you have an integer and a double value and an operation, so arithmetic operation, so we will be always converting the integer value into a double value and then perform the operation without losing any data. Okay. Right. Now, let us take another example. Now, in the example this one, so we have 6 divided by 4 plus 3.9. Now, when we are developing this expression, so we need to look at the way that we are going to operate this expression, right. So, now we have the multiplication, division and the addition. So, when you have the division and addition, so division has the highest level of operator precedence, right. So, therefore, we will be doing this operation first and then this operation second. Okay. Now, since we have 6 and 4 for the division, so that is the first operation we will be performing. So, 6 and 4 are two integer values, right. So, therefore, regardless of what you have for the addition, so for the division we have two integer operands. So, then the first operation will be performed as a integer division, right. So, therefore, 6 divided by 4 is going to be 1, and then we have 1 plus 3.9. So, now we have an integer and a double value. According to the previous example then, so we really cannot add these two together because they are two different types. So, we need to convert then integer into double and then perform this addition, right. So, then 1 will be converted into 1.0, and then we are going to add that one with 3.9. So, then it is going to be 4.9, right. Now, the third expression in here, so it is a little bit large expression with different data types and operations again. Now, we have the multiplication, subtraction, addition and the division. Now, according to the operator precedence rules, we know that multiplication and division has the same level of operator precedence. So, because of that, we are going to apply left to right rule. So, then this will be done first and then this will be done second, and then we have subtraction and the addition at the next level. So, again when you apply left to right rule, so this will be done third and then this will be done fourth, right. So, that is pretty much the order in which we are going to perform these operations, all right. So, then I would like all of you to figure the final answer. So, the most important thing here is then mainly the order in which we perform this operation. So, how to apply the operator precedence rules in here together with the mixed mode expressions, all right. Okay. Now, in general then, so when you are evaluating mixed expressions, that is where we have integers and doubles together. So, we are going to evaluate based on the operator precedence. If the operator are the same type of operands, so then we evaluate according to the operator precedence rules for the same type. Otherwise, if we have both types, that is integers and doubles, so integer is changed to a floating point, that is a decimal point value, and then operator is evaluated. The resulting value is going to be a floating point value, right. Okay. So, let us take one quick example regarding this operator precedence rules, how this type conversion happens. So, usually when this type conversion happens in an expression, that happens automatically, as the programmer really does not need to do too much. So, that type of a type conversion is called implicit type conversion, right. So, let us take one example. So, let us run through this program and then see how this program is going to do this evaluation. Now, in here then we have three integer values. So, num1, num2 and int dev, and then we have two double values. So, dnum1 and then a double dev. Okay. Now, in the first operation in here, so we are saying int dev equals num1 divided by num2. Now, num1 is going to be 5. So, num2 is going to be 2. So, then 5 divided by 2. So, that is the integer division. So, then this is going to be 2, right. So, then int dev is going to have the value 2, right. Now, there is no type conversion happens in here. The only thing that happens here is that when you divide 5 by 2, the decimal portion is discarded, right. Now, in this scenario, so we have double dev equals dnum1 So, d num 1 is 5.0. So, that is the double value, and then num 2 is an integer value 2. So, since we cannot divide exactly as it is, so we need to convert this integer value into a double value. So, before we do the division, so then it is 5.0, so divided by 2.0. So, that type conversion, converting 2 to 2.0, that happens automatically. So, that actually is the implicit type conversion happen at runtime, right. So, then the final value for this one is going to be 2.5. So, therefore, double due is going to have 2.5 as the value once you are done with the division, right. So, then output of this one is going to be 2 in the first line and then 2.5 in the next line, right. So, that is how the implicit type conversion happens with the mixed mode expressions. Okay. So, now it is time for us to do another quick checkpointing question and see if we got the idea related to the type conversions, implicit type conversions and the mixed mode operations. Right. All right. So, now when we talk about implicit type conversion, so we know that then the compiler automatically puts some data in there in the expression, so that type conversion happens implicitly without programmer explicitly specifying it, right. So, however, if the programmer really wants to explicitly convert one data type to the other, such as double value to an integer where we are going to lose the decimal point, so we still can do that. So, that type of a type conversion is called explicit type conversion. Usually, when you are doing explicit type conversion, so we will be using the static cast method in C++, right. So, let us take a quick look at this static cast method and then see how type conversion happens in there. Okay. Now, when you are using the static cast method, so we need to specify the data value that we need to cast into and also the data type that we want to cast into. Now, here we are saying convert 7.9 into an integer. So, when you are converting 7.9 into an integer, so what you are doing is pretty much we are getting rid of the decimal portion. So, then we will have 7 as the final value, right. So, we are not rounding it up, so but you are pretty much discarding the decimal portion, all right. So, given that then, so when you convert 3.3 into an integer, so then this value is going to be 3, right. So, likewise, if I want to convert 25, that is the integer value into a double value by typecasting, so then I can specify that convert 25 into a double value. So, that is going to be 25.0. Okay. So, now we have an expression here. So, we can still put an expression inside the typecast operator. Now, the first thing we do is then, so we do the arithmetic operation. So, in here the value is going to be 8. So, that is the integer 8, and then integer 8 will be converted into a double value, right. So, then this one is going to be 8.0. Okay. So, next one again. So, when you typecast 8 directly into a double, so then that is going to be 8.0 again. Okay. Now, this is an interesting scenario. So, in this case, so what you are doing is actually, so first we are typecasting 15 into a double value and then we are dividing that one with an integer value, right. So, now when you do this operation, the first thing that happens is that we are converting 15 into a double value. So, that will be 15.0. Okay. Now, we have 15.0 divided by 2. Now, we have a double value and an integer value in this expression. Now, according to the previous example, then we know that we need to convert the integer value into a double value. So, before we perform the division, right. So, then 2 will be converted into 2.0. So, that conversion happened implicitly, right. So, this is implicit type conversion, and then this one happening here is a explicit type conversion. So, both of them together. So, once you are performing this operation, then so final outcome is going to be 7.5. Okay. Now, if you go to the last expression, so then here we have 7.8, and then so we are going to typecast this results into a double value. So, now this operation when you are performing it, so we know that 15 typecasted into 15.0, and then when divided by 12, 2 is going to be 7.5. So, then 7.8 divided by 7, add 7.5 to it. So, then that is going to be 3, 15, and it's going to be 15.3. All right. So therefore, in a static cast method, so we can put expressions also inside the method operation. So then arithmetic operation will be performed, and then it will be typecasted into a double or integer value that we want to. Right. Okay. The other type that we want to briefly touch base with in this lecture is about representing data as constants. Right. So now that we can perform all the operations with integers, doubles, and mixed mode expressions. So there is another way we need to represent data sometimes. So if we have data values that will not be changing during the execution of the program, so it's a good idea to represent these data values as constants rather than variables. Right. So making them constants will make our program much more robust. So in the sense that we will not be changing those values even by mistake, because they are defined as constants in the program. Right. So usually when you are defining constants, so we use the constant keyword in front of the variable name, and then the data type, okay, and then the constant name. So when you have a constant name, usually constant names are designated with uppercase letters altogether. So that will kind of distinguish constants and variables. Right. So now if I want to represent, let's say, gravity, so gravitational force, so then it's a floating point or a double value. So then we can define it as a gravity and then put the constant value at the time of declaration. So after this value cannot be changed. So if you write an assignment expression to change this value, so it's going to throw an error saying constant cannot be changed. So that will safeguard against any mistakes during the execution of the program. Right. So likewise, if I want to represent, let's say, the phi value as a constant, so then it's going to be a constant, and the so floating point value, so it's 3.14. Okay. So likewise, if I want to have, let's say, number of days represented as a constant, so it's a larger name, so still it gives a meaningful name for the constant. So this time it's going to be an integer constant, so number of days per week, and it's going to be 7. Right. So that's how pretty much we represent constants. Now when you're using constants in an expression where we perform operations, so here's an example where we can use a constant in an expression. Suppose we want to calculate the area of a circle. So we know that area of a circle is phi r squared. Right. So then phi is 3.14. So then we can define phi as a constant, and then we can multiply it by radius 2 times to get the value for the area. So phi will be used in this expression. So phi is a constant. So this is an example where constants are used in an expression when you're performing computations. All right. Okay.